Let us see second example. Example number 2. Expansion with period 2l. Right on. Find the Fourier series expansion of the function f of x, which is given by f of x equals to within the limit minus 2 less than x less than 0, and it is x for 0 less than x less than 2, and f of x plus 4 equals to f of x. That means f of x is a periodic function with period 4. So in this case L equals to 2. Therefore the Fourier series expansion for the given function is given by f of x equals to a0 by 2 summation n varies from 1 to infinity an cos of n by x upon L means 2 plus summation n varies from 1 to infinity bn sin of n by x by 2. One by one we will calculate a0, an and n. So first of all we will see a0. a0 equals to 1 upon L means 1 by 2 integral minus 2 to plus 2 f of x dx. That can be written as half integral minus 2 to 0. Within this limit value of f of x is 2, so 2 into dx plus half integral 0 to 2. In this interval value of function is x, so x dx. So this is half integral of 2 is 2x within the limit minus 2 to 0 plus integral of x is x square by 2 within the limit 0 to 2. So put these limits and simplify. So half, when you put upper limit it becomes 0 minus lower limit minus plus 4 plus for this when you put upper limit 4 by 2 is 2, lower limit is 0. So this is 4 plus 2 by 2, that is 3. So a0 is 3. Then an is given by 1 upon L means 1 by 2 integral minus 2 to plus 2 f of x cos of n by x upon 2 into dx, which is equals to half, I can take common, integral minus 2 to 0, in this case f of x is 2 into cos of n by x upon 2 into dx plus integral 0 to 2, here f of x is x, so x into cos of n by x upon 2 into dx. Solving this integral and simplifying, we get so what values we get, a0 equal to 3. We are calculating an now. So continue this. An equals to half 2 into integral of cos n by x by 2 is sin n by x by 2 upon n pi by 2 within the limit minus 2 to 0 plus here x is first function, integral of cos n by x by 2 is sin n by x upon 2 upon n pi by 2 minus derivative of this x is 1, integral of sin n by x is minus of cos n by x by 2 upon n square pi square upon 2 square, that is 4. Bracket close and limits are 0 to 2. Substituting the limits, what we will find is how to, when you put x equal to 0, sin of 0 is 0, so upper limit is 0, And when you put x equals to minus 2, this is sine of minus n pi. Sine of minus n pi is also 0. So this is 0 plus. When you put x equals to 2, 2 into sine of n pi, that is 0. Minus minus plus cos of n pi 2 by 2 is cos n pi, that is minus 1 raised to n upon n square pi square by 4 upper limit. When you put lower limit, this becomes 0, and lower limit minus minus plus and minus. Cos of 0 is 1 upon n square pi square by 4. So simplify this. What we will find is half into, this is 0. So here 4 upon n square pi square, you can write here, and in the bracket you have minus 1 raised to n minus 1. Okay. That is an equals to 2 upon or 2 into minus 1 raised to n minus 1 upon n square pi square. So let us calculate Bn. Bn is given by 1 upon n, that is 1 by 2, integral minus 2 to plus 2 f of x sine of n by x upon 2 into dx. That is equals to half integral minus 2 to 0, value of f of x in this interval is 2, so 2 into sine of n by x by 2 into dx plus integral 0 to 2. In this interval, the value of function is x. So x into sine of n pi x by 2 into dx. Solving these integrals and simplifying, which is equals to half. Okay. Here this 2 you can take outside. Integral of sine n pi x by 2 is minus of cos n pi x by 2 upon n pi by 2. So this completes the integral. Limits are minus 2 to 0 plus. Now second integral. Here the first function is x. Integral of sine n pi x by 2 is minus of cos n pi x by 2 upon n pi by 2. First function integral of second minus derivative of x is 1. Integral of minus cos n pi x by 2 is minus of sine n pi x by 2 upon n square pi square upon 4. Let it close within the limit 0 to 2, and this will be the bracket. So simplify. So we obtain the value of an, which is equals to 2 times minus 1 raised to n minus 1 upon n square pi square. So continue. Bn equals to half. Now, when I put upper limit 2 into minus of cos 0 is 1, so that becomes minus 1. So 4 in upon n pi into minus 1. Okay. And when you put lower limit minus minus, this becomes plus. Cos of n pi minus n pi means cos n pi, that is minus 1 raised to n, and here remains 4 upon n pi. Okay. Plus here when you put x equals to 2, so this 2 and 2, this becomes minus 4 upon n pi 4 upon n pi cos of n pi is minus 1 raised to n, minus minus plus, when you put x equals to 2, sin n pi becomes 0, that vanishes, and when you put lower limit x equal to 0, this term vanishes, and when you put x equals to 0 here, this also vanishes. So the lower limit is 0. So simplify this, this is half minus 4, I will take this 4 upon n pi common outside the bracket. Okay, so this is minus 1, this is minus 1 raised to n, and plus this is minus 1 raised to, okay, this is minus. So finally, what I get is minus of 2 upon n pi. So Bn equals to minus of 2 upon n pi. So with these values of a0, an and bn, now we are able to write down the Fourier series for the given function f of x. F of x equals to a0 by 2, that is 3 by 2 plus summation n varies from 1 to infinity an. So an is 2 into minus 1 raised to n minus 1 upon n square pi square into cos of n pi x by 2 plus summation n varies from 1 to infinity bn. Bn is minus 2 upon n pi into sine of n pi x upon 2. If you further want to simplify, you can do that. 3 by 2 plus, here 2 by pi you can take outside, summation n varies from 1 to infinity minus 1 raised to n minus 1 upon n square into cos of n pi x by 2 plus here minus 2 upon pi I will take outside. This is summation n varies from 1 to infinity 1 upon n into sine of n pi x by 2, which is the required Fourier series of the given function f of x.